Hi dear. So you know how to balance a equation, right? So what is meant by equation, chemical equation? It is a simplest form of a simplest form to describe a chemical reaction, right? So what is the reactant? Reactants, your left hand side is your reactant and your right hand side is your product form. That is a new compound form, and the arrow indicates the direction of the reaction. So this is enough, but if you give a few more information about this equation, chemical reaction, it will be very useful and it is easy for understanding also. Okay, in the same equation we can describe the state of the equation, that means state of the elements. So whether it is in the form of a solid or liquid or gaseous form. Okay, so the next process, next step in the chemical balancing the chemical equation is that mentioning the physical state of the element. Okay, so what are the different states of the elements? Solid, liquid, gas and aqueous. Aqueous means it is a solution in water. That means what? Solution means what? It is a combination of solute and solvent, right? So here the solvent will be your water always. If you take a salt solution means you will be adding salt to the water, right? So that salt is your solute and water is your solvent. Okay, so we will mention that solution in water as aqueous in the equation. Okay, so it is represented by solid as S, liquid as L, gas as small g and aqueous as AQ. Okay, this is how we are going to represent. Okay, we will take some example. Magnesium plus oxygen gives magnesium oxide. You know that. First what is the step? First we have to balance the equation, right? Then we will mention what state it is. Okay, so how many here 1 mg. Now you are familiar with the balancing, right? So here 1 mg is there, here also 1 mg. Here 2 oxygen is present, so we have to make this product oxygen also into 2. So we will put 2 here. Okay, then it becomes 2 oxygen. Here it is balanced, but it becomes 2 magnesium here. So to balance this, we will put 2 mg, right? So 2 mg plus O2 gives 2 mgO. So right. So what state it is? So it is solid. We have burned the solid magnesium river. Remember that? Okay. So it is solid state, and oxygen is the gas form, and your MgO, magnesium oxide, we collected it as a ash, right? White powder. So it is also solid. Clear? This is a well balanced equation which describes the physical state of the elements also. Okay. So now take this example. Fe plus H2O gives ferric oxide plus hydrogen gas. It is not required to mention all this physical state every time. Okay, if they ask, for example, this hydrogen, this evolution of gas is occurring in this reaction means at that time you have to mention this is gas. Okay, it is not necessary unless it is mentioned or required. Okay, but you just have to know all this thing. Okay, so first balance the equation. We put the column. Fe is there, H is there, O is there. Okay, right? Reactant side and your product side. How many Fe is there? 1 here, 2H here, 1O. Product side 3 Fe is there, and oxygen is 4 and hydrogen is 2. Okay, so first we will balance this oxygen. So here 4 oxygen is there, here only 1 oxygen is here. So we'll make it to 4, right? So we'll put 4 here because only oxygen is present here. No other option. We have to make changes here only. Okay. So now oxygen becomes 4 here into 4, that gives 4. But hydrogen becomes 8 here into 4, that is equals to 8. So we have to make this hydrogen here also 8. So how to make this? 2 4s are 8. So we put 4 here. So 2 4s are 8. Iron is Fe is 3 here, so we'll multiply, put 3 here, multiply by 3 will give 3. 3, 8, 4, 3, 8, 4. So 3 Fe, 3 Fe, 8 hydrogen and 4 oxygen, 4 oxygen. Now it is balanced. Okay. So now we'll mention this state. Fe is in the form of solid, water is liquid, and your Fe3O is, this is also in the form of solid, and this is gas, hydrogen gas. Clear how to write the balanced equation with the physical state of the elements, right? Next, we'll give more information about this balanced equation by mentioning the condition also. At what condition? In the presence of what? Okay, you know, for example, take the photosynthesis. Photosynthesis takes place in the presence of sunlight. Sunlight is important, so we will not mention, we will not write that sunlight in the equation. So where we will mention the condition of the reaction? Above or below the arrow mark. Okay, so reaction condition, like at what temperature it has to be reacted. சும்மா இப்படி பக்கத்துல வச்சுனா it will react? No, it will not react. At what temperature it can react? So temperature, under what pressure? Okay, you can convert the gas into liquid by liquid under pressure, right? So at what pressure? What is the catalyst used? Catalyst is nothing but a chemical which speed up the process or slower the process, slow down the process. Okay, or indicated above and or below the arrow mark, above or below the arrow of the equation. So take this example, carbon monoxide plus hydrogen gas, and this is your gaseous form, carbon monoxide. Hydrogen is also gaseous form. Then this methyl alcohol, methyl alcohol we can say, otherwise we can call this as methanol. This is liquid. When how this gas will combine together to form a liquid? Under a greater pressure. I think 340 atmospheric pressure. Okay, under 340 atmospheric pressure, this gas combined to form a methyl alcohol. Clear on this? So is it balanced? I didn't check this one. One carbon, hydrogen is 4, but here only 2, so we will convert into 4 here, 4 hydrogen, 1 oxygen. So now it is balanced. Okay, clear? Next, we'll see one more example. This CO2 plus, just now I told you, this photosynthesis process. Carbon dioxide plus water in the presence of sunlight and chlorophyll will get glucose, right? Glucose plus oxygen plus H2O, water, right? So first we'll try to balance the equation, then you'll mention the state of the equation. Okay, so what are the elements present in there? Carbon, oxygen and hydrogen. In the reactant side, 1 carbon, oxygen is 2 plus 1, 3, and hydrogen is 2. Okay, in the product side, how many carbons? 6 carbons are there, and this oxygen, how many are there? 6 plus 2, 8, 8 plus 1, 9. Okay, next, hydrogen, 12 plus 2, 14 hydrogen are there. Okay, first we'll try to balance this. Usually we'll take this highest number of atoms, then we'll balance it, but here only in one place carbon is present, so no other way, carbon has to be 6. Here product side carbon is 6, means here also we need to put 6, right? 1 6 6 becomes 6 CO2 plus H2O. Now it is balanced. O and 2 are present in 3. Oxygen is present in 3 places, now hydrogen is present in 2 places. We'll try to balance this one. So we'll first try to balance this hydrogen. So here in the product side it is 14, here it is only 2. So if you put 7 here, If you put 7 here, it becomes equal, hydrogen become equal. What about that oxygen? It becomes here 7, already here 12 is there, 12 plus 7 19, you will get 19 oxygen, right? Here this side it will become it is already only 9. Okay, so we if you put 7 in the place before water, oxygen is not balanced, so we should not put 7 here. So we'll check with 8. If you put 8, 8 it becomes, this side it becomes 16, and here this become 14. 14 means again will not be able to balance. So this is only a trial and error method, right? So we can try with the numbers. So if you check this 7, 8, 9, I tried with that. So 7, 8, 9, 10, 11, it does not work with this number in the place of hydrogen. Okay, so the final number is what? 12. So if you put 12 here, this hydrogen become 24. Okay, so already we are having 6 carbon here, we should not change this part. Okay, so already here 12 hydrogen is there, we make it to 24, means 12 plus already 2 is here, so 6. If you put 6, it becomes 12 hydrogen, here also 12, 12 plus 12 24. So this become 12 plus 12, that is equals to 24 here. What about oxygen? If you put 12 here, the oxygen become here 12 plus 12 24, right? So we should not touch this part, so we cannot make changes here. So already 6 is there, here also we are balanced. So 6 plus 6 12, 6 plus 6 12, but we need 24 oxygen. So if you put 6 here, it becomes 12, right? Here 6 plus 12 plus 6, so totally 24. The product side it become 6 plus 6 plus 12, that is 6 plus 12 plus 24. Here this becomes 12 plus 12, that is equals to 24. Okay, now it is balanced. 6 CO2 plus 12 H2O gives, in the presence of sunlight and chlorophyll, will get glucose. This is the formula of glucose. Glucose plus 6 O2 plus 6 H2O. Okay, so it's little bit difficult, so it's easy way to remember this balanced equation is actually how this glucose is formed. Means you need 6 CO2 plus 6 H2O. If you have 6 H2O plus 6 CO2, glucose will be formed. See, H12 is there, H12 is there, and O6 is there, O6 is there, 6C is there, C6 is there. So you are so if you add 6 CO2 plus 6 H2O, you will get the glucose plus 6 oxygen. Okay, remaining is 6 oxygen is there. So now here we are having extra 6 H2O here, extra 6 H2O here, right? Sorry, here in the balanced equation we are having 6 H2O here, here 12 H2O. So we need one more 6 H2O to be added on both sides, here in reactant side and also product side, 6 H2O. So we added 6 H2O here. Here already 6 is present, so if you add one more 6 water molecules, it become balanced now. Okay, so to get glucose we need only 6 CO2 plus 6 H2O. So the product will be glucose plus 6 O2. So if you add 6 H2O in both the sides, now it is a balanced equation. Clear on this? So what is the state of these equation? Finally, this is aqueous. Always carbon dioxide is readily combined with the water. Okay, it was always in the aqueous state, and this is, water is liquid. So this is your reaction condition. Under the sunlight only photosynthesis process will take. If there is no chlorophyll, then photosynthesis process will not take place. So under the presence of sunlight and chlorophyll, this process is taking place. And this is your aqueous. Okay, aqueous. And oxygen, this is also in the form of aqueous. It is readily in the form of aqueous combined with water. And this, this is your liquid. Okay. Next, I will see some book examples. Solution of barium chloride and sodium sulfate in water reacts to give insoluble barium sulfate and solution of sodium chloride. First, you will try to convert the word equation to a skeletal equation. Solution of barium chloride. You know the formula of, now you are familiar with this formulas. Barium chloride chemical formula is this one, barium chloride. Solution means what? Then it is in the aqueous state. Okay, right? Reacts and sodium sulfate in water. Sodium sulfate in water means it is mixed in water. So it also become a solution. So it is your aqueous condition. Next, gives insoluble barium. Insoluble barium sulfate. Barium sulfate formula this is. So insoluble means then it is a solid. And the solution of sodium chloride. Sodium chloride formula, you know that's NaCl. Solution of sodium chloride. Then this is also mixed in water. So this is also in aqueous state. Okay. We'll check now whether it is balanced or not. 1Ba, Cl2 here. So here this side, reactant side 2Cl is there. So we'll convert this into 2Cl. Now this sodium became 2. Already 2 sodium are present here. The reactant side SO4, SO4. Now it is balanced. Clear? Next. Sodium hydroxide solution in water reacts with hydrochloric acid solution in water to produce sodium chloride solution and water. Okay. Sodium hydroxide solution in water ne kuduta. Okay. Sodium hydroxide NaOH aqueous. Because it's solution form. Okay. Reacts with hydrochloric acid. Hydrochloric acid means HCl. Okay. That is also in hydrochloric acid solution in water, so mentioned. So this is also aqueous. Okay. Produce sodium chloride. Sodium chloride NaCl, they said sodium chloride solution. That means this is also aqueous. Okay. Next, plus water. And water they mentioned. So and water is a liquid, Clear? Now balance the equation. Na 1 Na 1 Na. Okay. OH, how many O is there? Only one O is there. Here also one O. Hydrogen 1 2 is there. Here also 2. Cl 1 is there. 1 Cl is there. Now it's balanced. Already it is balanced, right? 1 Na 1 Na 1 Cl. Hydrogen 2 1 oxygen. Okay, clear? So this is complete a balanced chemical equation mentioning the states, reaction condition, at what condition it is reaction is taking place, as well as in what state the elements are reacting, whether it is a solid or liquid or gaseous or aqueous condition. Okay, thank you.